In this lesson, we will be solving quadratic application problems. I have three examples for you where you're given a paragraph of information, and inside of that paragraph, there is a formula which we will use to create an equation. The type of equation we end up with is a quadratic equation, and our zero factor theorem will be the technique we use to solve that equation. Once we have the solutions, we'll be able to determine how to answer the question being asked. In our example, an object is thrown upward from the top of a 208-foot building with an initial velocity of 192 feet per second. The height h of the object after t seconds is given by the quadratic equation h equals negative 16t squared plus 192t plus 208. When will the object hit the ground? So when they say when, they're talking about time. So they have a question about time. So we're trying to figure out how long is it going to take for this to happen? And they give us a hint. They tell us that the object hits the ground. Well, if the object hits the ground, that means it has a height of 0 feet off of the ground. Because they give us this description. We have a building. Here's the ground. Here's the building. The building is 208 feet in height. Oops. 208 feet in height. And this object is being thrown upward, and it's supposed to come down and hit the ground. When it does, that's what we're talking about when we say a height of 0 feet. So it starts off 208 feet high and ends up at 0 feet when it hits the ground. We're going to use this as a hint. If we're talking about being at 0 feet, that means h gets 0 plugged in for it. So that formula they've given us turns into an equation that we'll be able to solve. So here's our equation. 0 equals negative 16t squared plus 192t plus 208. Now, if we go back to our zero factor theorem from the previous lesson, we know that we need to have factors with 0 on one side and factors on another. And right now we have the 0, but we don't have the factors on the right side. So we are going to have to factor. Notice that our trinomial starts with a negative 16. That means factoring by grouping, unless I can get a common factor out of there. Now, I'm hoping 16 goes into all the terms. I'm going to use my calculator to check. If not 16, maybe 8 or 4. Just trying to make that 16 smaller would make the factoring easier. It turns out that 16 does go in. And since my first term here is a negative, I'm actually going to factor out a negative 16. And it's going to go in t squared minus 12t and then minus 13. And that makes things a lot more manageable. Notice that we have 1t squared minus 12t minus 13. That means I'm going to be able to factor with my factor pair shortcut. So I'll have these two binomials ready to go once I figure out the factor pair. So I'm going to say 1 times negative 13 equals negative 13, and I need to add the negative 12. That actually turns out to be the factor pair too, negative 1 and positive 1 and negative 13. So my factors, t squared will be t and t, and then plus 1 and minus 13. So remember that the process is we take the factors that have variables in them and set them equal to 0 to make easier, smaller equations. T plus 1 is 0, or t minus 13 is 0. So I'll continue to solve. I'm going to subtract 1 off of both sides here to get t equals negative 1. Or in this case, I'm going to add 13 to both sides to get t equals 13. Now, remember that t represents time, so that when they say what time, I don't think negative 1 seconds makes sense, but 13 seconds does make sense to me. So I'm going to use the 13 on this to answer. Sometimes we get more than one solution that doesn't answer the question. Maybe part of it will, and so in this case, that's what's happening. So my answer to this is, when will the object hit the ground? The object will hit the ground at 13 seconds, or in 13 seconds. So that's my answer. The object will hit the ground in 13 seconds. So on these problems, you will make an equation, you're going to solve it, and then you're going to answer it. That's the expected number of steps in these types of word problems. So let's look at a second one. In this one, an object is dropped 59 feet below the tip of a pinnacle atop a 255-foot tall building. The height h of the object is given by that equation. Find how many seconds pass before the object reaches the ground. So in this case, we have our building, which happens to be 255 feet. That's how tall it is. And again, they're asking about, when does the object hit the ground? That's the h is 0 feet. Notice though in this one they talk about this, or they have the number 196 in there, which is kind of interesting. They did tell us that there is like a ledge that is 59 feet, 59 feet below the tip. So here's the tip. So this is where the 196 comes from. If I took 255 and subtracted out 59, I would get the 196. So if you're wondering where the numbers in the formula come from, that's where they're coming from. So just like before, the h is 0. So I'll make my equation. 0 equals negative 16t squared plus 196. And I checked to see if 16 goes into 196, but it doesn't. So then I checked to see if 8 goes in, and it does not. And then eventually I check to see if 4 goes in, and 4 does go in. So I'm going to try negative 4 because of the first term. I'll get 4t squared minus 49. Okay. So notice that I end up with a difference of 2 squares. That means my factorization will be rather quick. What do I square to get 4t squared? 2t. What do I square to get 49? 7. And then so I have 1 with a subtraction, 1 with an addition, and I'm going to create equations in each of these cases set equal to 0, and now I'm going to solve. In this case I will add 7 and get 2t equals 7, divide by 2. Normally I would say 7 halves, but I'm not a fan of fractional time, so I'm going to divide that out to either be 3.5 or 3.5. As a mixed number. Here I'm going to continue solving, but just like on the previous problem, I end up with a solution for t that doesn't really work in my answer. Negative 3.5 seconds doesn't make sense. It says how many seconds pass before the object reaches the ground, and so the answer here would be the object will reach the ground at 3.5 seconds. Notice again, I created an equation, I solved it, and then I answered the question. Those are the 3 things that we want to have in these application problems. Create the equation, solve the equation, and then answer. So the last example, similar type problem. If the cost C for manufacturing X units of a certain product is given by C equals X squared minus 25X plus 65, find the number of units manufactured at a cost of $10,415. So they're wanting us to find the number of units. So the number of units, that's the X part. And then the cost, that's the C. So we can use that information to create an equation. So that means for C, I'm going to plug in 10,415 is equal to X squared minus 25X plus 65. Remember on these problems, we need a 0 on one side. So I'm going to subtract 10,415 off of both sides. Now it's going to give me 0 equals X squared minus 25X. And then that, if using my trusty calculator, I'm going to get negative or minus 10,350. Here's the good news. The good news is we have a trinomial that starts with a 1, so we can use the factor pair shortcut. The bad news is that we're still working with negative 10,350. So it's definitely a calculator exercise. Negative 10,350. You want to run the factor pairs on this. 1 and negative 10,350. That does not add to the middle term of negative 25. So I'm going to try something a little bigger. Negative 10 times negative 1035. If I add those, it's still not adding to negative 25. So I'm going to kind of up it a little bit. Let's try 50. Let's see what happens with 50. With negative 207 in my calculator, that takes me to negative 157 if I add them. I'm getting closer. So I'm just going to keep trying the 60, 70, 80, and so on. This is definitely a calculator problem. Eventually I find out, though, that 90 does go in, and it goes in negative 115 times. And when I add those together, I do get negative 25. So, here's the thing. You do have to use a calculator on something like this, but you can just keep asking it. Does 10 go in, 20, 30, 40, 50, 60, all the way to 100? And how does that look when I add those numbers together? So when I come back over, then I'm going to say, okay, this is 0. And then I'm going to factor here x squared. I need x and x. And then I'm going to do a plus 90 and a minus 115. Now I can make my equations. X plus 90 is 0, or x minus 115 is 0, and then I'll subtract 90 for the first. X equals negative 90, or add 115 for the second, and x equals 115. So, x is the number of units. It doesn't make sense to make negative 90 units. So that means that this part of the solution will answer the question in our problem. So the question here is, how many units? Find the number of units manufactured at this cost. And something like there were 115 units manufactured would be a good answer. Okay, so again, just to reiterate, I made an equation, I solved it, then I used that information to answer the question, and both solutions to the equation did not answer the question, but one of them did. And again, I just used logic. Negative 90 units doesn't make sense. So the examples with these application problems should all be set up the same way. Create an equation from the formula, solve using the zero factor theorem, and then answer the question using the information that you determined from your solutions.